Hello everyone. Today we're going to do section 2.3 and section 2.5. Let me start with section 2.3. In section 2.3 we have linear inequalities. Okay, but let me get my markers first. Okay, these are linear inequalities. Actually, yes, linear inequalities. So here is an inequality, the first one. Give you this one first. Here we go. Suppose we have the following. Suppose we have this one. I'll just make one up. 2 times x minus 3 over 2 times x plus 1 is greater than or equal to 1/4 times x plus 2. That's a linear inequality. Okay? The first thing we're going to do is we're going to get rid of fractions. Okay? We're going to get rid of fractions. To get rid of fractions, I'm going to multiply every numerator by the LCD. The LCD in this case, we're going to find the least common denominator between 2 and 4. Obviously, the LCD is 4. We're going to multiply every numerator. If you see parentheses, you're not going to worry about them. You're not going to worry about parentheses. Okay? So, let me multiply every numerator by the LCD. I'm not going to worry about parentheses. We'll take care of parentheses once the denominators are gone. That's when we worry about parentheses. Okay, so therefore, the LCD is 4. LCD equals 4. So I'm going to multiply every numerator. Listen to me. Every numerator I'm going to multiply by 4. That's a numerator over 1. By 4. That's a numerator, and this is a numerator. But I'm not going to worry about this parentheses. By 4. Another numerator right there. By 4. What is that going to do? That's going to get rid of fractions. Okay. So here, what's 4 times 2x? 8x. What's 4 times 3? 12. And what's 12 divided by 2? 6. So this is minus 6 times x plus 1 is greater than or equal to, the 4's cancel. And it's 1 times that. 1 times x plus 2. Note, I don't worry about parentheses when I multiply every numerator by the LCD, trying to get rid of fractions. We don't worry about parentheses until the fractions are gone. Okay? So note, I multiply this by the LCD 4, got 8. Multiply this by 12 over 2, which is 6. Multiply this by 4, the 4's cancel, and I get 1. Okay, so now I'm going to worry about parentheses. Okay, now I will worry about parentheses. Note, I'm going to have to distribute. By the way, when this 6 goes in, guess who goes in? Well, the 4 times the 3 divided by 2 they all go in. Why? Because 4 times 3 divided by 2 is 6. That's why I got the 6. So when the 6 goes in, they all go in. The 4 times the 3 divided by the 2. So in essence, everybody is going in into this parentheses. No one is being cheated, including this 4. The 4 also goes in. The 3 goes in. The 2 goes in, the denominator goes in. 6 goes in. When 6 goes in, they all go in. Okay? So like I'm saying, we don't worry about parentheses until fractions are gone. Okay? So distribute. 8x minus what? 6x minus 6 greater than or equal to, distribute, x plus 2. By the way, when this 1 goes in, the 4 times the 1 divided by 4, they all go in also. That's how we got a 1. Okay. Note, I started with this inequality. This is a linear inequality. That's a linear inequality. And note, if it has fractions, we find the LCD, and then we multiply everything, every numerator. Don't forget this now, every numerator by the LCD. And here we go. And so now I'm gonna simplify, and so therefore we get 8x minus 6x is 2x minus 6 greater than or equal to x plus 2. Okay, I'm going to subtract this x from both sides. Just bring this x to the left. And I'm going to add 6 to both sides. When I do that, this is what happens. That's a 2x. Bring it over. Minus x. Take it over. A 2 plus the 6. Okay? And so we get x is greater than or equal to 8. So this is the answer to the original problem. What was the original problem? That's the original problem. If you plug in a value that's greater than or equal to, if you plug in 8, this is going to be true. If you plug in 9, it's going to be true. If you plug in 8.5, anything that's greater than or equal to 8 will make this true. If you plug in a 7, it's going to make this false. If you plug in a 0, because 0 is less than 8, it's going to make that false. Try it. Plug in 0. Plug in 0. Okay? If you plug in 0, that's 0. That's 0. And that's 0. If you plug in 0, that's 0. And that's 0. If you plug in 0, this is negative 3/2 times 1. Because that's 0. What's negative 3/2 times 1? If you plug in 0. If x equals 0, that's going to be false. I know that already. Why? Because here's the solution. 8 or greater than. Okay. Plug in 0 there, 0. Plug in 0 there, 0. What's negative 3 times 1? Negative 3/2 greater than or equal to. Plug in 0 there. What's 1/4 times 2? Is negative 3/2 greater than or equal to 1/2? No. See? If you plug in a 7, it's going to make this false. Oh, but if you plug in a 9, it's going to make it true. Plug in a 9.5, it's going to make it true. Okay? So therefore, we can also graph the solution. We can graph the solution, guys. Graphing the solution. If you want to graph the solution, look at this. Graphing the solution. Here is 8, circle 8, shade 8, everything to the right. That's the solution. Okay. You can also give the solution in interval notation. Interval notation is this, is 8 all the way up to infinity, including 8, so you better use brackets. You never get to infinity, so it's parentheses. So this is the graph. This is interval notation. And then we also have set notation. And set notation is basically this. We say answer is x such that, and then write that, x is greater than or equal to 8. That's set notation. This is the graph. This is interval notation. And this is set notation. Okay? All right. Let's do another one. Okay? Let's do one more. Here's another one that we can do. Here's a good one. Yeah, let's do this one. Watch this one. Okay? Let's do this one. Okay, so I'll give you this one. Look, here's a good one. I'm giving you the hard ones, okay? Because I believe you can do the easy ones. But here's a good one. Here is 2/3 times 1 minus 2x minus 3/2 x plus 5/6x greater than or equal to 2x minus 1/6 plus 1. There it is, look. Okay, so I'm going to multiply everything by the LCD. What's the LCD between 3, 2, and 6? 6, right? Because this 6 goes into 6, this 2 goes into 6, and this 3 goes into 6. So therefore the LCD is 6. LCD equals 6. So let's multiply everything by the LCD. When I say everything, I mean every numerator. Let's multiply every numerator by the LCD. Okay. I'm going to multiply this numerator. I'm not going to worry about parentheses because I will worry about it later. What's LCD? 6. That's a numerator, and that's also a numerator. Believe it or not, numerator also. Should be up there. 6. That's a numerator, and that's a numerator. That's 5x. What is this? Multiplied by 6. Oh, that's a numerator. Multiplied by 6. You better use parentheses because 2x minus 1 is a numerator, it's a binomial. Oh, that's a numerator. 6. All right. Now, we're going to simplify. I'm not going to worry about this parenthesis until this fraction is gone. So there's 2 different ways. You can multiply 6 times 2, which is 12, divided by 3, which is 4. Or you could say 3 goes into 6 2 times, and that 2 times this 2 is 4 again. So this is 4. This is 4 times 1 minus 2x. 2 goes into 6 3 times. 3 times 3 is 9. Minus 9x. The 6 cancels. And what do we get? Plus 5x. The 6 cancels. And what do we get? 2x minus 1. Plus what? Plus 6. See? No more fractions. Okay. Now, distribute combine like terms. Okay, I can combine those two if I want to. I think I will. And I'm going to combine this one and that one. Sure, why not? I'm going to distribute. What's 4 times 1? 4. What's 4 times negative 2x? Negative 8x. What's negative 9x plus 5x? Negative 4x. That's a 2x. And what's negative 1 plus 6? Plus 5. Okay. Combine like terms. That's a 4. And what is this? Minus 12x greater than or equal to 2x plus 5. Okay. I don't know. I think I'll bring this 2x to the left because I want to show something. Bring this 2x to the left and bring this 4 to the right. So when the 2x comes to the left, we get what? The negative 12 is already there. This 2x comes to the left, minus 2x, greater than or equal to. Bring this to the right. So that's a 5 minus 4. Okay. All right, so here, what's negative 12x minus 2x? That's negative 14x. Greater than or equal to 1. Now, here's what I want to stress. If I'm going to solve for x, I need to get rid of this minus 14. How do I get rid of the minus 14? Well, I get rid of the minus 14 by dividing both sides by negative 14. Guys, when you divide or you multiply an inequality by a negative, the inequality symbol reverses. Okay, so therefore I'm going to divide this by negative 14 and I'm going to divide this by negative 14. Whenever you divide or you multiply an inequality by a negative, you must reverse the inequality symbol. So I divide this by negative 14, okay? Watch what I'm going to do. Negative 14x divided by negative 14. And this is 1 divided by negative 14. Because I did that, this inequality symbol reverses. The negative 14 cancels negative 14. And a positive divided by negative is negative. So therefore, the answer, let me write the answer in red. So therefore, x is less than or equal to negative 1 over 14. There you go. All right. Very good. Okay. I want to make sure that everything's okay. Okay, it's fine. Now, that's the answer. We can graph the answer now. Let's graph the answer. I'm going to graph the answer. I'm going to graph the answer right below. Here's the answer. Go to negative 1 over 14. Circle negative 1 over 14. Shade negative 1 over 14. And it's everything to the left. That's what it says. And now, if you want to do the integral notation, from negative infinity all the way up to negative 1 over 14, including, if it's including, you use brackets. If it's excluding, that means if it does not have equal, that's excluding, you use parentheses. Okay? Now, negative infinity is always on the left. And positive infinity is always on the right. So from negative infinity, which should be on the left, all the way up to negative 1 over 14, and this one is excluding, because you'll never get there. Okay? And the set notation is x such that x is less than or equal to negative 1 over 14. And there you go. Okay. Now sometimes the inequality may have 3 sides. No problem. If the inequality has 3 sides, that is not a problem. Given a problem with an inequality with 3 sides. Here we go. With 3 sides. Where is a good one? Okay, there's one right there. I see it. Look at this one. 1/2 is less than or equal to 1 minus 2x over 3, less than 2/3. That has 3 sides. Okay, no problem. Here's side 1, side 2 in the middle, and side 3 to the right. 3 sides. They all get treated the same. Okay? They all get treated the same. I'm going to multiply every numerator by the OCD, and the OCD is 6. 2 times 3 is 6. So let me multiply this by this numerator by 6. This numerator, if it is parentheses, by 6. And this numerator by 6. And that's going to get rid of fractions. Now you tell me what's half of 6? 3. That's a 3. The 3 goes into the 6 2 times. Nope, I don't worry about parentheses because I shouldn't until fractions are gone. 3 goes into 6 2 times, so 2 times 1 minus 2x. Okay? Was 3 into 6 2 times, and 2 times 2 is 4. There you go. So this fractional inequality, no more fractions. Okay? Now I'm going to distribute this 2. And so we get a 3 less than or equal to 2 times 1 is 2, and 2 times negative 2x is negative 4x, less than, and that's a 4. Okay. Now, I need to isolate this x. So there's 2 things I need to do. I need to get rid of this negative 4, which is being multiplied, and I need to get rid of this 2, which is being added. I'm going to take care of this 2 first. I'm going to subtract. This 2 is being added. I'm going to subtract. Subtract 2 from all 3 sides. Subtract 2 from here. So watch this, what I'm going to do, okay? 3 less than or equal to 2 minus 4x less than 4. And now I'm going to subtract 2 from the middle, 2 from the left, and 2 from the right. All 3 sides. Okay? No, I have not lost my inequalities. And so what's 3 minus 2? 1. What's this 2 cancels as negative 2. We get negative 4x. And what's 4 minus 2? 2. Now, I'm going to divide everything by negative 4. And what did we say that we must do when we divide an inequality by a negative? We said we have to reverse the inequality symbol. So let me take this, I'm going to divide it by negative 4. Let me see. So 1 divided by negative 4. And this negative 4x divided by negative 4. And this 2 divided by negative 4. And this inequality symbol is going to reverse. And this one is going to reverse. There you go. Okay. Now, so this is negative 1/4. So negative 1/4 greater than or equal to x greater than, simplify this, negative 1/2. Okay. Now, that's the answer. But when you read the answer, you always start from the variable. Okay? Yeah. Look, here's my point. My point is that this is the answer, but this is not written correctly, because you know very well that the smaller value is always on the left. You know that. Between 10 and 2, 2 should be on the left, right? We say 2 on the left is less than 10 on the right. The smaller value is always on the left. And that's not the case here. This is the greater value, and this is the smaller value. Negative 1/2 is smaller than negative 1/4. Okay? Think about it like this. This is a quarter, and you owe a quarter. And here, this 50 cents, half is 50 cents. You owe 50 cents. Where do you owe more? Here. You're in debt here more than here. So this is the smaller value, but it's on the right. It's on the right. Look at it. This should be on the right. So this is what we do. We take this inequality and we reverse it. All of it. Reverse it. Okay? So let's do that. Let's reverse it. Or if you want to, you could just read from the variable. Look at, it says x is less than or equal to. So x is less than or equal to negative 1/4, and x is greater than negative 1/2. That's the way it should be written. Don't forget that. And now we have the interval notation. Interval notation from negative 1/2. Look, no equal, excluding, all the way up to negative 1/4. Oh, there's equal, including. Okay? And if you want to graph it, go to the graph, go to negative 1/2, circle it, go to negative 1/4, circle it, and this one, negative 1/4, is shaded, and it's everything in between. And there you go. That's the solution. And if you want to make it in a set notation, no problem. It's here, x, such that all of this takes place. And there you go. Okay, very good. So this is section 2-3. Okay? All right, very good. I think I'm going to go on to the next section already. By the way, section 2-4, we're going to skip let's go on into section 2.5. Okay, section 2.5. In section 2.5, we are going to do absolute value equations. Okay, absolute value equations. Good class. In section 2.5, we're going to do absolute value equations and inequalities. 2.5. So let me erase this. Okay, so absolute value equations. All right. All right. So there's three things you need to learn. 3 rules. Here's the first one. If the absolute value with a dog inside, look, that's the absolute value with a dog inside, equals to a constant. If you have an absolute value with a dog could be a mathematical expression. If you have the absolute value, these are absolute value with a dog inside equals to a number, a constant. To solve this, you bring out the dog out of the absolute value house. So if this is the case, then bring out the dog equals k, or dog equals negative k. You must say this to bring out this dog from inside the absolute value house. You must say that. Okay? Don't forget. The dog equals to the same k, the positive k, and the dog equals to the negative k. What's an example? Here's an example. Suppose we have the dog absolute value. There's the house. Let's put a dog inside. 2 minus 3x plus 4. That's the dog. That's inside. Equals to, when we say, let's say 2. This is exactly that. How are you going to solve? Okay, treat this like this property. Okay? The property says if you have the absolute value of a dog equals to a k, or constant, then the dog, look, no more absolute value, okay? No more. The dog equals k, or the dog equals negative k. So therefore, by this rule, the conclusion is, what's the dog? The dog is what's inside. 2 minus 3x over 4 equals 2, or 2 minus 3x over 4 equals what? Negative 2. Okay, I'm just following this. That's all I'm following. Now, how do you solve? Well, multiply this equation by 4, both sides by 4. Okay, multiply this by 4, and this by 4. Multiply this by 4, and this by 4. Okay, the 4's cancel, and so what do we get? 2 minus 3x equals 8. Or, let me use or, okay? This is the union. Or, what about this? 4's cancel. 2 minus 3x equals to negative 8. Okay. Now, let's solve for x. subtract 2. So minus 3x equals 8 minus 2, which is 6. Or minus 3x equals negative 8 minus 2, which is negative 10. Divide both sides by negative 3. So that x, what's 6 divided by negative 3? Negative 2. Or, what's a negative divided by negative? Positive. So that x equals to 10 thirds. And that's the solution. We have two solutions. Okay? Now, if you have the dog, the house, if you have the absolute value house being multiplied by a number outside, or added or subtracted to a number outside the house, you need to use this conclusion, you need to isolate the absolute value house. Let me give you an example. Okay. All right, so let me get rid of this. Here's another example. So watch this. Five times absolute value. 2 minus 9x divided by 3, close the house, absolute value house, plus 2 equals to, I'm going to say, 12. Okay. So this is almost this, except for the fact that this absolute value is by itself. This absolute value equals k is by itself. Before you use this property here, you better get the absolute value house by itself. So let's get rid of this 2 first, and then we'll get rid of this 5. Never distribute the 5 into the absolute value. Never multiply this 5 into the absolute value house. Mistake. So subtract 2. So 5 times 2 minus 9x over 3, close it, equals what's 12 minus 2? 10. Okay, never multiply whatever's being multiplied times the absolute value house, never bring it inside. It's a mistake. Instead, you need to get rid of it the following way. To get rid of this 5, I have to divide by 5. Divide this by 5. Divide this by 5. Okay. The 5's cancel, and what do we get? Absolute value of 2 minus 9x over 3. Absolute value equals to what? 2. Oh, now this is like this property, the absolute value house with the dog inside, is by itself. Absolute value house with the dog inside. We're ready to use that conclusion. By that conclusion, what's the dog here? 2 minus 9x over 3 equals 2, or 2 minus 9x over 3 equals negative 2. There you go. Okay. By that property. Let's multiply both sides by 3. Multiply this parentheses, okay? Parentheses by 3. The 3's cancel, and multiply this by 3. Okay? I'm going to show you this time. by 3 by 3 by 3 by 3. Okay. The 3's cancel. And so what do we get? 2 minus 9x equals to what? 6. Or 2 minus 9x equals to what? Negative 6. And so, solve for x. Subtract 2. So negative 9x equals to what? 4. Or negative 9x equals to what? Negative 8. Okay. Divide both sides by negative 9 so that x equals to negative 4/9, or x equals to, what's a negative divided by negative? Positive 8/9. And there's the solution. Okay? That's beautiful. Beautiful. Okay. Here is another property. Do they have it here? Yes, they do. Here's another property. Okay? So that's property number 1. Here's property number 2. Property number 2 says the following. Number 1, number 2. If the absolute value of dog is greater than, if you want to say equal to, you can, it doesn't matter. Equal to or just greater than constant, then the dog, look, the dog comes out, is greater than constant, or the dog is less than negative of the constant. Okay, that's property number 2. Example. Example, watch this. Example. Three times absolute value of 5x minus 4 over 3 absolute value plus 2, let's say plus 4 is greater than or equal to, let's say 16. Okay. All right, very good. We must isolate the absolute value house first, just like before. If you're going to use this conclusion, you better isolate this absolute value house, have it by itself. Okay? So you need to get rid of this 4 and you need to get rid of this 3. This 3 never cancel this 3 and that 3. It's wrong. You can't do that. Don't do it, okay? Don't distribute. Never do that. These are not parentheses. They are absolute values. Instead, you can get rid of this 3. But first, let's get rid of this 4. How do you get rid of the 4? Subtract 4 from both sides. Okay? This 3 and that 3 cannot be canceled. No. So this is 3, absolute value, 5x minus 4 over 3, absolute value, is greater than or equal to, what is 16 minus 4? 12. Okay. I got rid of this 4. Now let me get rid of this 3. This 3 and that 3 do not cancel. That's tempting. Yes, it is. It is tempting, but it's no. That's not the way it's done. Okay, to get rid of this 3, I cannot get rid of this 3 yet. But to get rid of this 3, let's divide both sides by 3 by 3. This 3 cancels this 3. Yes, it does. And so what do we get? Absolute value of 5x minus 4 over 3. Close it. Is greater than or equal to what? 4. Okay. Now I have this case. Look, the absolute value is greater than constant. Absolute value is greater than or equal to constant. Okay. Let's bring the dog out. Let's say the dog is greater than constant, or the dog is less than the negative of the constant. Okay, here's the dog. The dog is greater than or equal to constant, or the dog is less than or equal to negative of the constant. Okay, so the dog, here we go, I'm going to continue here. So the dog, 5x minus 4 over 3 is greater than or equal to constant, which is 4, or 5x minus 4 over 3 is less than or equal to the negative of the constant. There you go. That's how you get rid of inequalities, okay? That's how you do it. All right, class? Okay, beautiful. Almost done. Almost done. Let's multiply everything by 3. Now I can get rid of this 3. You know how to do it. Multiply this by 3. By 3. Multiply this by 3. By 3. That's how you do it. The 3's cancel. What do we get? 5x minus 4 greater than or equal to 12, or 5x minus 4 less than or equal to negative 12. Okay. Add 4. So 5x is greater than or equal to, what's 12 plus 4? 16. Or 5x less or equal to, what is negative 12 plus 4, negative 8. Divide both sides by 5. So x is greater than or equal to 16 over 5, or x is less than or equal to negative 8 over 5. Okay. Beautiful. Now, if we ask you to graph the solution, how do you graph the solution? To graph the solution, go to 16 over 5, circle to the right. Negative 8 over 5, circle to the left. That's the solution. If you want to give it in interval notation, from negative infinity all the way up to negative 8 over 5, including, excluding, or from 16 over 5 all the way to positive infinity, including, excluding. Okay. All right, very good. One more property. Note, the absolute value of dog is greater than constant, okay? And one more property. Here's another property. This is the absolute value of a dog greater than constant. Okay? Number 3. If the absolute value of the dog is less than constant, when the absolute value is less than constant, here, the easiest thing to do, put the dog in the middle, okay? Take it out of the absolute value and put the dog in the middle. Then, the dog in the middle. Dog, note, no more absolute value, is greater than negative k, less than k. That's what I meant. Put the dog in the middle between negative k and k. Put it in the middle. That's what you do when the absolute value of dog is less than constant. Example. How about 15 times the absolute value of 2x minus 3 over 3 absolute value plus 5 is less than or equal to, let's say, 20. Let's say 30. Yeah, let's say 30. 30. Okay, look, it's the third property. But first, let's get rid of this 5 and let's get rid of this 15. Do not simplify this 3 and the 15 at this stage. That's a huge mistake. Okay, the first thing, we're gonna get rid of this 5 and then we're gonna get rid of this 15, not using this 3. No. So subtract 5 from both sides. So 15 times absolute value, 2x minus 3 over 3, absolute value is less than or equal to 30 minus 5 is 25. Okay? Now let's divide both sides by 15. So divide this by 15. Divide this by 15. You better simplify that, okay? The 15's cancel. And what do we get? Absolute value of 2x minus 3 over 3. Absolute value is less than or equal to, simplify this, 5 goes into 25, 5 times, 5 goes into 15, 3 times. Okay. The absolute value of a dog is less than constant. And what did we say? What did we say to do? Put the dog. Take this dog out of that absolute value house and put it in the middle between negative k and k. Okay? I'm going to take 2x minus 3 over 3 out. Here we go. 2x minus 3 over 3 is no longer in absolute values, and I'm going to put it in the middle. Less than or equal to 5/3, greater than or equal to negative 5/3. There we go. Okay. Put the dog in the middle. That's what I did. Let's multiply everything by 3. Multiply this by 3 and the 3's cancel. Negative 5. Multiply this by 3 and the 3's cancel. 2x minus 3. Multiply this by 3 and what do we get? Add 3 to all 3 sides, because I want to get rid of this 3. Add 3 to this. What's negative 5 plus 3? Negative 2. What's 2x minus 3 plus 3? 2x. What's 5 plus 3? What's 5 plus 3? 8. I added 3 to all 3 sides. Negative 5 plus 3 is negative 2. 5 plus 3 is 8. And add 3 to this and get rid of that negative 3. Divide everything by 2. Divide this by 2, negative 1. Divide this by 2, x. Divide this by 2, 4. Okay, there it is. You can graph it if you want to. Go to negative 1, circle negative 1, shade negative 1. Go to 4, circle 4, shade 4, and it's everything in the middle. If you want interval notation is negative 1 up to 4, including negative 1, including 4. Okay. If you want set notation, the answer is x such that x is less than or equal to 4 and greater or equal to negative 1. And that's the answer. Okay? This section 2.3 and 2.5.